Good morning, students. Today's lesson, Unit 11, Carbon and its compounds. Unit 11, Carbon and its compounds. The topics, functional group, suffix for IUPAC name, International Union of Pure and Applied Chemistry, IUPAC rules for naming organic compounds, IUPAC nomenclature of hydrocarbons. Today's topic, functional group, suffix for IUPAC names, rules for naming the compounds, IUPAC rules for naming organic compounds, IUPAC nomenclature of hydrocarbons. First, IUPAC rules for naming organic compounds. This is classes of the compound: alcohol, aldehyde, ketones, and carboxylic acid. Classes of the compound: alcohol, aldehydes, ketones, and carboxylic acid. The functional group of alcohol is OH. The functional group of aldehydes, CHO. Functional groups of ketones, CO. Functional group of carboxylic acid, COOH. Alcohol, OH. Aldehyde, CHO. Ketones, CO. Carboxylic acid, COOH. The suffix name is used for the functional group. Based on the functional group, the suffix name is used. For alcohols, OL. The compound end with the name OL. The suffix name OL. For aldehydes, AL. For ketones, ONE. The suffix name ONE. Carboxylic acids, OIC acid, that is oic acid. Alcohol, functional group OH, suffix OL. Aldehydes, functional group CHO, suffix AL. Ketones, functional group CO, suffix ONE. Carboxylic acid, functional group COOH, suffix OIC acid, that is oic acid. Then how the name is given to the compound. Some of the rules we have to follow. Rule 1, identify the longest chain of carbon atoms to get the parent name. Parent name means a root word. So this is the longest chain of the carbon in this compound. This is an example. The compound is given here: CH3, CH2, 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 CH3. First, identify the longest chain of carbon atoms to get the parent name, that is root word, which is the longest chain from the given compound, which is the longest chain. First, we have to identify. Then, rule 2, number the carbon atoms. For example, here 1 carbon, 2 carbon, 3 carbon, 4 carbon, and 5 carbons. So, number the carbon atoms of the parent chain, beginning at the closest end of the substituent. Substituent means branches or the functional group. That is substituent or functional group. These are called local numbers. If both the functional group and the substituent, that is branch, are present, then the priority will be given to the functional group. Next, rule 3. In case of alkenes, that is double bond, we know already alkanes single bond, alkenes double bond, and alkynes triple bond. In case of alkenes, that is in the double bond, and alkynes triple bond, locate the double bond or triple bond and use its locant number. So the given number, so this is a branch, so locant number is 2. Here 1, 2, this is locant number. Followed by a dash, that is hyphen, whether it is single bond or double bond, and a primary suffix. Then rule 4, if the compound contains functional group, so here no functional group. So sometimes alcohol OH, carboxylic acid COH, ketone CO is also given in the compound. If the compound contains functional group, locate it and use its locant number. So this is the locant number for this compound. That is, locant number means closest end of the functional group or nearby the branch, followed by a dash and a secondary suffix. And then rule 5. When the primary and the secondary suffixes are joined, the terminal E of the primary suffix is removed. Example, for the compound of CH3OH, the name is methanol. So, only one carbon, so meth is the prefix word. Primary suffix, this is combined with the single bond, so ANE is the primary suffix. This is functional group, this functional group is OH, that is alcohol, so end with OL, this is secondary suffix. Meth, based on their availability or present in the number of carbon atoms, so here only one carbon, so meth is the prefix word. So this all one combined with the single bond, so N is the primary suffix. Based on the functional group, here OH is the functional group, so secondary suffix OL. So name of the compound is meth plus N plus OL. Here the E is only to be removed, so that is METHANOL. Remove the letter E, that is methanol. Name of the compound is methanol. Rule 6. Identify the substituent and use a number followed by a dash, that is a single bond, and a prefix to specify its location and identity. Then IUPAC, a nomenclature of hydrocarbons, that is classification of hydrocarbons. Example 1, the compound is CH3CH2, CH2CH2 CH3. How to give the name for the compound? Step 1, it is a 5 carbon chain, 1, 2, 3, 4, 5 carbon chain, and hence the root word is pent. Meth, eth, prop, but, and pent. So here 5 carbon atoms, it is a 5 carbon chain, and hence the root word is pent. 1, 2, 3, 4, 5 carbon atoms. So if it is only one carbon, meth is the root word. 2 carbon, eth is the root word. 3 carbon, prop is the root word. 4 carbons, meth, eth, prop, but is the root word. Here 5 carbon atoms, so meth, eth, prop, but, and pent. Pent is the root word. Step 2, all the bonds between carbon atoms are single bond. Here, in between carbon and carbon combined with a single bond, and the suffix is "an". So this is a single bond, so "an" is the suffix word. So its name is pent plus "an", pentane. Based on the presence of carbon atoms, 1, 2, 3, 4, 5 carbon atoms. So the prefix word is pent. So it's combined with a single bond. So "an" is the suffix, primary suffix word. So pent plus "an", pentane. The name of the compound is pentane. Then example 2, CH3, CH2, CH2, CH3. This is a local number here, CH3. The step 1, naming of the compound, that is a rules. As per the rules, follow the steps. First step 1, the longest chain contains 5 carbon atoms and hence the root word is pent. 5 carbon atoms, 1, 2, 3, 4 and 5 carbon atoms. The longest chain contains 5 carbon atoms and hence the root word is pent. There is a substituent. Here this is called substituent. So that is branch. So the carbon chain is numbered from the left end. Here this is the left end, which is closest to the substituent. So this carbon is closest to the substituent, that is a branch. So the number is to be started from the left end. There is a substituent. This is a substituent. So the carbon chain is numbered. So that for example 1, 2, 3, 4, 5 numbered from the left end. This is a left end, which is closest to the substituent. Then all are single bonds. Here in between the first to second carbon, second to third carbon, third to fourth carbon, fourth to fifth carbon is all one combined with the single bond between the carbon atoms, and thus the suffix is "ane." The suffix is "ane." Next, step 3. The substituent is a methyl group. This is a substituent is a methyl group. CH3, that is methyl group. If it is a C2H5, that is ethyl group. Here CH3 is only present in the substituent. So that is methyl group. This is called methyl group. The substituent is a methyl group and it is located at the second carbon atom. So here number from as per the rule left end nearby the local number. So 1, 2, 3, 4, 5. The substituent is a methyl group. This is a methyl group and it is located at second carbon atom. Here second carbon atom is located in the second carbon atom. So its local number is 2. This local number is 2. The prefix is 2-methyl. So the name, that is the place is 2 and this is a methyl group. So the prefix is 2-methyl. Then the name of the compound is 2-methyl. 2 that is in the place of the local number, that is 2. This is a methyl group, so methyl, 2-methyl, and 5 carbon atoms, 1, 2, 3, 4, 5 carbon atoms, so pent. So all one is combined with a single bond, so ane. So 2-methyl pentane. This is the name of this compound. Next, example 3. CH3, CH2. This is a branch. Then CH3, CH, CH2, 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 CH3. Step 1. The longest chain contains 7 carbon atoms. 1, 2, 3, 4, 5, 6. And left hand side to right hand side. Here, left to right, here only 6 carbon atoms. 1, 2, 3, 4, 5, 6. From the top to, that is from the branch to long chain, that is 1, 2, 3, 4, 5, 6, 7. So this is the longest chain from the branch to the long chain, that is 7 carbon atoms. Only in the longest chain it has only 6 carbon atoms. So we have to calculate the 7 carbon atoms chain. The longest chain contains 7 carbon atoms and hence the root word is hept. Meth, eth, prop, but, pent, hex and hept. 1, 2, 3, 4, 5, 6, 7. Totally 7 carbon atoms. The longest chain contains 7 carbon atoms and hence the root word is hept. Then step 2. All are single bond between the carbon atoms. Here first to second, second to third is also combined with the single bond only. All are single bonds between the carbon atoms and thus the suffix is ane. So the single bond, so a suffix is N. Next step 3, the substituent is a methyl group. So this is a methyl group. Here this is a methyl group. Substituent is a methyl group. And it is located at third carbon. Here 1, 2, 3. So the methyl group is located at third carbon, nearby the third carbon. So its local number is 3. This local number is 3. Thus the prefix is 3-methyl. So the place is 3. So this is a methyl group. So 3-methyl. And then hence the name of the compound is 3-methyl. 3-methyl and hept plus N. 3-methyl hept plus N. That is 3-methyl heptane. Then there is a numbering from the branches to long chain. Here 1, 2, 3, 4, 5, 6, 7. From the left to the right, there is only 1, 2, 3, 4, 5, 6. So this is the wrong method. Okay, so we have to taken as the long chain of the carbon atom. And then example 4, the given compound is CH3, CH2, CH2, CH, a double bond CH2. Here a double bond is present. Step 1, it is a 5 carbon atom chain and hence the root word is pent. 1, 2, 3, 4 and 5 carbon atoms. It is a 5 carbon atom chain and hence the root word is pent. Meth, eth, prop, but and pent. Step 2, there is a carbon to carbon double bond. Here carbon to carbon double bond. So the suffix is ene. So single bond is present, the suffix is ene. If the double bond is present in any one of the place, so the suffix ene is used. Then it is a 5 carbon atom chain and hence the root word is pent. There is a carbon to carbon double bond, the suffix is ene. And step 3, the carbon chain is numbered from the end, such then a double bond has the lowest local number. Double bond has the lowest number. So from given the number for the compound from right to left, the carbon chain is numbered from the end, such that double bond has the lowest local number. So double bond has the lowest number, which is the lowest local number. This is only taken as an account for naming of the compounds. A double bond has the lowest local number as shown below the diagram. Now this is the compound diagram. That is CH2, CH, CH2, CH2, CH3. So step 4, the local number of the double bond is 1. Local number, this is local number. Local number of the double bond is 1 and the suffix is 1-ene. So the name, the place of the double bond is the first place, so 1. So the double bond, so ene, this is a suffix. So the name of the compound is pent. Totally 1, 2, 3, 4, 5. From left to right, there are 5 carbon atoms. From right to left, here also 1, 2, 3, 4 and 5 carbon atoms. So from left to right or right to left, so totally 5 carbon atoms. But the double bond is only nearby this carbon atom. So from right to left is the correct method. 1, 2, 3, 4, 5. The local number of the double bond is 1 and thus the suffix is 1-ene. So the name of the compound is pent. 5 carbon atoms, so pent is the first prefix and the place 1. Double bond, so ene is the suffix. So name of the compound is pent 1-ene. So the name of the compounds, we have to follow some of the rules. Thank you, students.